Hello, everyone. And thank you for having invited me. Thank you for coming to the lecture. It's actually summer outside, so it's very strange. And today, I would like to present you some of the work that I have been doing for the last 12 years and discuss some new agenda that we would like to bring in the Fab Labs, which has to do with textile and materials. So I imagine that most of you inside here have a better understanding of what are the Fab Labs. And I don't need to further explain what it is about. Is very quickly an outreach program from MIT that started around 17 years ago, and it seeks to socialize. And I say socialize, I don't say democratize, because democratize has to do also with politics, but socialize is different. Seeks to socialize access to new technologies, and it does this by setting some standards of tools, of machinery, equipment. There is an inventory, but the most important part is the part where you have brains, that it's about a share and open sharing and open thinking. So I have been in this network for 12, 13 years now. And in 2013, I thought that I would like to open a new track, a new agenda that has to do with the expansion of the Fab Lab to textile labs and eventually to material labs. Which means that if you think that a Fab Lab is a puzzle model, then you just have an add-on of a textile and an add-on of a material or biolab, if you want to call it. So I created this addition, this plugin, and that is called the Fab Textiles. And it has been a research lab initiated in the Institute of Advanced Architecture of Catalonia and Fab Lab Barcelona, where I did my studies. And of course, this was the beginning of bringing this type of agenda. It was not that other people were not doing it already, but it was somehow making it more formal, that we need to think of other disciplines that they need to come in this space, apart from engineering or technical or coding or hackers. And we need to think about soft fabrication. We need to think about artistic creation, performance, arts, and different topics. So like many of you here, I imagine, I wear many hats. I do many different things. And we all, I think, share if we're coming from the same background, we all share the feeling that we are the ones actually that they're the artists behind the artist that is making the things work for someone that wants to make a production or making the things happen, a reality. And so I wear different hats. One is the Fab Textiles, the research lab. The other is a program that I funded in 2016 with colleagues of the Fab Lab Network, which is called the Fabricademy. And then I have been curating and producing exhibitions around digital fabrication, biofabrication, and wearable technology. I have been working in European projects of creative industries, Creative Europe, and the last one that I'm currently finishing has to do, it's called Shemakes, and it has to do with bridging the gender gap in innovation through skills and community. And also I form part of the collective which is called Remix Biodesign. It's a collective of designers that they're working with food surplus and digital craft. And I was in Namur like 1.5 months ago because I also participate in the exhibition in Le Pavillon. So there is an exhibition currently about, it's called Biotopia, and it is about biomimicry, bioinspiration, symbiotic design that I will talk about later on. So it is very nice to be here in Namur. Actually, I wanted since the first KIKK to come here, and it's somehow a dream comes true after all these different years. At that point, with different projects, now with different projects. And everything somehow is connected. So all the hats, they are mutating and connecting. Everything is related to each other. I established like this research agenda that it tackles 4 topics. And today the presentation is more here to inspire you. So I will be talking through projects. The first one is how we can use digital fabrication for the textile and clothing industry. So tackling specifically an industry that has a lot of margin to improve. Then about wearable technology, augmenting our bodies, our senses through electronics. Then biofabrication, working in circular design and sustainability. And then in parametric design, where we do not think about designing products anymore, but we think about designing systems that can generate different products. And the Fab Textiles manifesto is being very creative. Basically, don't lose your creativity ever. Design and make your own materials, your tools, and your processes. And especially when we are talking about material innovation, we need to understand that if we are inventing a new material, then probably we will need to make also some kind of tool that will work with the material, and probably it will be very custom process, fabrication process. So it's to think in a holistic way, manufacturing. So craft materials, design your tools, and invent your processes. And all of this it has some objectives, like why am I doing this? And it's good to reflect every now and then when you're inside technology and things are moving very fast. It's good to step out at some point and say, okay, why am I doing all of this? So I think that one part of my practice has been a lot about reflecting when we are inside the Fab Lab, how we can make the processes more sustainable. Because indeed, when you're working in the cutting edge new technologies and in the prototyping field, because you want to make something that probably maybe will go out to the market afterwards, but you are prototyping, there is a lot of loss and there is a lot of use of resources because it is a test, no, it's a prototype. So you can. So my question was how we can promote sustainable and open manufacturing, combine the locality but also the globality. How we can unbox this black box of technology by using open source practices and social innovation and co-creation. How we can create communities of practice that they are global, about sharing and caring, and also being very radical into the way we consume, we produce, we approach products, processes, and markets. And lastly, being critical on making and reflecting, which is rethinking the role of tools and technologies. I'm not saying that we should be technophobists, but I'm not saying that we should be techno-lovers either. I think that we should be reflecting on both and positioning ourselves consciously into where we position our practice in front of technologies. And again, I think that everything is interrelated and connected. So if you go on my website, Fab Textiles, it is quite old, an old school type, because it is like a blog post, and it was the easiest way for me to be able to share my recipes and my tutorials. It's all made of different posts that you can learn how to do things, from making a simple t-shirt to creating your own coffee leather bag. And you can find a lot of open patterns and open resources how to extract pigments from pomegranates, for example, all different things. And it has around 100 posts now, so it's quite being adding upon all the years. I'm not very much into maintaining it, but I have been also working a lot, as I said, in exhibitions and curations. So unfortunately, COVID stopped us for some years, but every year I make an open call to bring together different artists and creators that work in this field of intersecting digital fabrication, biotechnology, and textiles. And we've done around 10 exhibitions in the last 13 years. And the Fabricademy is where all of this self-practice is put into a curricula, a program that is running in many Fab Labs all over the world in a distributed way. And it follows the basic principle and the basic program of the Fab Lab Network, which is called Fabricademy, how to do almost anything. So it is the daughter program, following the practices and using the same infrastructure, that says that education is also radically changing nowadays, because at the end of the day, most of the times we will Google something to learn how about it. And this was not the case 10, 15 years ago. So we see that we need to update the educational system as well. And this practice has been very pioneering in the Fab Lab Network since 10 years now with the Fab Academy. It is the program now run from Neil Gershenfeld, the creator of the Fab Labs. And when he called for opening this to academy, so he said, let's make more academies, we came with a proposal of bringing the Textile and Technology Academy into the Fab Lab Network. And we have been running this program since 6 years. So it is very young, starting to go to school now, so 6-year-old program. It has been a very, very nice journey in collaboration with many labs all over the world. So the research agenda of the program is about sustainability, Industry 4.0, which is digital fabrication, wearable technology, and innovation narratives. And I would like to go through some examples to show you what we are talking about and how we are transiting from some type of fabrication to different types of fabrication. So in the sustainability, we talk about the future eco-pioneers and material designers for circular and sustainable textile and clothing field, that we bring together the craftsmanship knowledge, the biodesign, biology, and chemistry. So it has to do a lot with STEM education as well, because here we are crossing the digital fabrication, which is use of laser cutting, 3D printing, modeling, with chemistry and biology. And we are talking about implementing material and bio labs inside the Fab Labs. And this helps us to be aware of how our materials are created, where do they come from, but also it helps us program and design our materials from scratch, which means that, okay, I have the possibility to fabricate everything I want, but where is my material coming from? And this is quite powerful. In the first topic, we talk about living materials, materials that are growing, working with mycelium, the root part of fungi. Here we are creating a statue of a mannequin that it grows, the mycelium grows on it and eats the cardboard. Or we are working with bacterial cellulose, which is, many of you know kombucha. Do you know kombucha? Is the green tea. This recipe actually is an open source recipe from pioneer Susan Lee. And we just learned how to do the practice, and we were able to create in the lab grown leather from bacterial cellulose. And of course, we started doing different variations of kinds of leather that we can make to grow this leather, and also how to natural dye it, how we can modify the pH of it, and how we can really get into big, thick sheets of bacterial cellulose. Bacterial cellulose is derived from also the tree, but the process to extract this pure cellulose from the nature is extremely complicated and energy intensive. So the method of growing bacterial cellulose in the lab is a lot more sustainable. And it is something that everybody can do at home. Then there is a process of transforming this into leather. And there are some practices and tricks, but of course everything is documented in an open source way. So if you want to learn how to do it, you can go on the webpage and see what kind of finishings you need to do in order to dry your bacterial cellulose and make it into leather. And the most nice part is that this material can be formed into any type of 3D shape. In this case, we are using a CNC milled mold, which is numerically controlled cut wood, to let the leather dry on the shape directly, which is also a different form of making garments, no? It is also a little bit like using the felting technique, if you know about hat making. Just using a mold and being able to design a mold with using parametric design as well. On the right, you can see a laser cut modular bacterial bag. And here you can see how the piece comes out when you just dry it, and then you can also dip it into a dye bath and color it if you want. Here's closer. Oh, sorry. So we have also been working with mycelium, and mycelium in this case, you can use it, as I showed in the beginning, for creating biocomposites. You can think of the mycelium as a glue, or as something that will put and consume and digest the things. So we have been doing tests of, for example, mycelium digesting the cigarette butts. Because cigarette butts are made of, the inside of them, it's made of cotton, and mycelium feeds on cellulose. So we see how the mycelium has regenerative features that they can actually consume that. And in this case, it's a very weird image. You cannot understand anything actually about this. In this case, you see the mycelium growing on that part. It is a research project of my student this year, that she's working on using the textile waste and making the mycelium feed on the textile waste to create leather biocomposites. So she wants to create textile, a non-woven new textile, by feeding on a wasted textile, so completely circular design. And in this case, there were previous experiments of making mycelium grow into fiber structures and seeing how, for example, the fiber knit or woven, it can reinforce the mycelium to make different kind of non-wovens. In the topic of living materials, also we think, and there have been quite a few projects developed about having a symbiotic relationship with nature. A lot of our students, they are really want to have an immersive experience with embodying nature. And this is the project of my student that she spun wool with seeds, and then she grew her poncho. She created a loom. She made her own tools. She created her loom, and she was taking care of growing this poncho that then afterwards she was able to wear. And this came as a kit, so her project is a kit where you can actually take the weave with a loom, spray with a spray, it's a ceramic print spray, and then after you can grow your own poncho and wear it. Or other student that she creates this root-based non-woven textile. So she makes 3D printed molds where she puts the grass to grow, and then the roots, they start weaving. It's a very known technique of Diane Schrerer. She's an artist that has been doing this for many years. So at the end, we want to show that with this practice, we are currently in this era that we call Anthropocene. It is an official unit of geologic time used to describe the most recent period of Earth history, when human activity started to have significant impact on the planet's climate and ecosystem. Actually, today in the workshop that we had in biomaterials in the morning, we were showing that the biomass of the globe, the total biomass of the globe, 2 years ago, it was smaller than the anthropomass. So basically, 2 years ago, the humans overpassed everything that was constructed by humans, past the amount of everything that was constructed by nature. So, so this is the era that we are living, but what we want to do and show with this practice is that we need to shift from the Anthropocene to the Symbiocene. And the Symbiocene is the era of companionship, is the era of living together, and when life on Earth is not destroyed, but instead is nurtured by humans. Because humans are nature, actually. We are very natural, if you think about it. We have nothing to do with... we are trying to imitate nature through technology. And I really liked 2 days ago this tweet from Ginkgo Bioworks. It says, the future won't be mined, extracted, or wired, or launched. It will be grown. So this is what we want to bring also as a topic, and we think that digital fabrication and bioengineering, biotechnology are also some means, but they are not means only for R&D and closed companies. They are means for everyone, and everyone should be able to understand this. Because unfortunately, and this is kind of like a reflection, is that we see nowadays that we have, for example, vegan burger. And the vegan burger, we imagine, I say, yeah, that's so cool, there is no meat. But it is making us completely detached of how this is made. We cannot imagine, at least like the meat of the cow, we understand there is a cow, people killed it, and then it came to our house somehow. But then when we hear a vegan burger, we don't really see the manufacturing process there. And that's scary because it makes us put more steps in between the consumption and the production. And what we want to do in the Fab Lab Network is to bring these two very close so that the consumer becomes the prosumer. So it's not that you are anymore only consuming, you are producing for your needs. And then we also want to tackle the heritage. So we think that we need to learn from the past in order to be able to move forward in the future. And here it's also this reflection because there was Buckminster Fuller that said that very technological, super inspiring engineer, an architect, that he said that in order to reinvent the things or in order to make innovation, you need to create something radically new that makes the current model obsolete. And I have been reflecting on that so many years, and I said, yes, but how can I make something obsolete if I don't know how really the things are working or how the things have been working for so long? So it's important to learn from the past. And in this case, the question is, do you know, for example, where the color green or the color red comes from? Do you know, like, where the color blue comes from? Maybe blue, you know. Maybe blue is like indigo is something very, very famous, like naturally. Where does it come from? So the bad news is that it's only since 1896 that we forgot where colors come from, because we invented chemical colors. And before that, we have a history from the caveman that is painting the caves with all of these mineral colors. Then we have all the natural dyes. We have the guilds from India that were hiding how they make indigo from the Chinese. So it's a big, big history of where color comes from, and suddenly we forgot about it completely. And this is at least sad, we can say. So we have been also working a lot into bringing this this color natural dyeing process, which is kind of crafty, but at the same time it puts you understand different principles of chemistry, because you play a lot with the pH, you can make chemical reactions. So apart from the colorful outcome, which is also feeding you with happiness, because it is known that the molecule of color is the one that has the anti-cancerogenous properties in the vegetables that we eat. It is also making us happy somehow. Apart from that, you get to learn how you can play with the ranges, the shades. You can make chemical reaction, extract pigments, make pastels, make crayons, make olive oil paints. So here is an installation that I made, which is called the color bar. And you can go to, it's in a bar, and you can go and you can have a shot of a different natural dye that you have extracted. That was part of also of the remixel Barrio. And the idea also is to start co-designing with living organisms. In this case, we use again the color molecule, but from a bacteria. And these are called living colors. And it is introducing us to basic principles of biology, and learning how to create a sterile bubble where you can work and inoculate different organisms or replicate. And in this one, we are using chromobacteria different ones, the ones that they can create the purple and the ones that they create pink. And these ones, we can make them grow on fabrics. So directly they can dye the fabrics without the use of any water. And they can start colonizing the fabric and giving it its color. Here you can see the tie-dyeing technique. It's when you fold actually the fabric. In Japanese, it's called shibori. So you can combine, again, a very traditional craft, which is tie-dyeing technique that has been used since ages, with biotechnology, understanding how we can work with living organisms and how we can color the fabrics. Here you can see the different outcomes according to how you fold it. And here you can see the collaboration that I had with one fashion designer. I prepared for her the different fabrics, and then after she created the garments. And here I hope that it will work. Yeah. Doesn't work? Let's see. So, sorry about that. Stop. No. Okay. So, at the end of the day, because I have to finish my talk, unfortunately, and at the end of, and I only talk about the one of the four research areas. I talk about the sustainability. I didn't even talk about the wearable technology or the industry 4.0, but it's okay. But in the end, at the end of the day, in this case, where we work with living organisms, there are a lot of further questions, like, are we extracting, like, why we are using it, like, there's a lot of ethical topics to tackle in this field, but at the end, we also want to question the role of the designer. And here I will quote my friend from Precious Plastic, which is an ingenious guy that made all of these recycling plastic machines that he open sourced, and now you have everywhere on the world. the ability to make a business out of recycling plastic. So he said that, unfortunately, in our society, our culture, it has made us look into the designer as a stereotype, as a role model. And when you go and you study design, they tell you, yeah, look at Philip Stark, or look at, I don't know, Eames, Ray and Charles Eames, or look at, who else? Alessi, I don't know. And we need to kill this, because it's never about the one, and it's always a lot of pressure in the one. And he said it's time to kill David Hackney. Hackney, I think his name from Precious Plastic is David Hackney. So it's time to kill this figure of the one designer. It's time to see that it's a collaborative work and many people are behind it, and there cannot be only one person that takes both the good and the bad side of visibility. And also, in this case, we are asking who is the designer, because there is the bacteria, the living organism that does the job, and we are providing the environment, we are providing the conditions, we are providing the pattern, the way the fabric is folded. And after reflecting for a long time about who is the designer, and I don't know what you think about it, I said, okay, but does nature care about who is the designer? Maybe nature doesn't really care about it, so why should we? So that's my finish. I will not continue with the rest. Thank you.